A garage in Central Florida, August. The air sits on your skin like a warm, wet towel that will not let go. Inside the house, a 5-ton air conditioner grinds through its 18th straight hour. Last month, the electric bill landed at $412. In the corner of that garage sits a $10 bag of white crystals quietly pulling water out of the air before it ever reaches the cooling coil. By the end of this video, you will discover the one number that proves your air conditioner wastes most of its energy fighting moisture instead of cooling your home. Outside Valdosta, Georgia. The owner has been growing there for 31 years. His cooling bill in July used to run over $6,000 a month. When I walked through the main growing house door, the air hit me cool and dry. I expected the roar of oversized air conditioning compressors. Instead, I heard a low, steady hum from a flat panel mounted above the main intake duct. He told me it was a desiccant unit, a system that strips water from the incoming air before that air ever touches the refrigeration coils. His compressor now runs at roughly half capacity. His July bill dropped from $6,000 to $2,200. I pulled out a hygrometer and measured the air coming off the desiccant panel, 41% relative humidity. Then I walked outside and measured 10 feet from the greenhouse door, 87%. That panel had cut the moisture load by more than half before the air conditioner ever switched on. The active ingredient inside that desiccant panel is calcium chloride, the same chemical sitting on the shelf at your hardware store in the de-icing aisle for about $10 a bag. Nobody walking past it realizes what it can actually do. For 3 decades, this grower paid thousands every summer to fight humidity with brute force refrigeration. Then he installed one system that fights humidity with salt, and his compressor has been coasting ever since. The technology is not new. It is not experimental. It is running right now in commercial greenhouses, hospital ventilation systems, and supermarket climate controls across this country. Quietly, efficiently, without any involvement from your residential HVAC contractor, because your contractor was never trained that it exists. The question worth asking is simple: why did this technology never make it into your house? That answer starts over a century ago, and it involves an industry that decided your comfort should depend on the most expensive machine they could sell you. Your air conditioner does 2 jobs every time it turns on. The first job is sensible cooling, lowering the temperature of the air. The second job is latent cooling, pulling water vapor out of the air by chilling the evaporator coil below the dew point until moisture condenses on the metal surface and drips into a drain pan. In humid climates like Florida, Georgia, Texas, and the entire Gulf Coast, that second job consumes a staggering share of total cooling energy. Your machine is spending electricity wringing water out of the atmosphere like squeezing a sponge with a refrigerator. Engineers have known this for over 100 years. In 1902, a young engineer named Willis Carrier stood inside the Sackett and Wilhelms Lithographing Company in Brooklyn, New York, trying to solve a humidity problem. Paper was warping in the summer damp. His invention was not primarily about temperature, it was about moisture control. The birth of modern air conditioning was a dehumidification project. Carrier filed his patent in 1906 and founded the Carrier Engineering Corporation in 1915. By the 1920s, his company had launched the Weathermaker campaign, selling Americans the idea that mechanical cooling was the only modern path to comfort. But the oldest dehumidification technology on Earth was not a machine. It was salt. For centuries, builders packed hygroscopic salts and quicklime into cellar walls and ship holds to control damp. Calcium chloride is a deliquescent salt, meaning it pulls water vapor from the air so aggressively that it dissolves into its own liquid. This chemistry predates the compressor by thousands of years. Persian builders use salt beds and lime plaster in underground storage chambers to keep food dry through summers exceeding 115 degrees. The physics worked before electricity existed. In 2011, engineer Eric Kozubal at the National Renewable Energy Laboratory in Golden, Colorado, built something remarkable. He called it DVAP, Desiccant Enhanced Evaporative Air Conditioning. The system uses a concentrated liquid salt brine to strip humidity from incoming air and couples it with indirect evaporative cooling. No compressor, no chemical refrigerant. NREL published results showing energy savings between 40 and 80% compared to conventional air conditioning. Their briefing noted that air conditioning alone consumes over 12% of all electricity generated in the United States, 40 to 80% savings on 12% of national electricity. Those numbers represent hundreds of billions of dollars in utility revenue that would vanish. At the Fraunhofer Institute for Solar Energy Systems in Freiburg, Germany, researchers have spent decades developing solar-driven desiccant evaporative cooling for buildings. Their work feeds directly into International Energy Agency programs. In Sweden, the engineering company Munters built an entire global business on desiccant dehumidification wheels installed in factories, warehouses, and commercial buildings worldwide. In Singapore, researchers at the National University developed water-absorbing gel systems for tropical climate control. The technology is proven, it is documented, it is deployed at industrial scale on 4 continents, and none of it reached your living room. The American HVAC industry generates $130 billion in annual revenue, and it is growing at nearly 7% per year. Every dollar of that revenue depends on one assumption: that cooling and dehumidification must happen inside the same machine using the same compressor, consuming the same electricity. Imagine executives sitting in boardrooms looking at a chart that shows what happens to unit sales if homeowners discover they can strip humidity from the air with a salt solution and cut compressor runtime in half. That chart goes in one direction, down. In 1927, the first model mechanical codes emerged with heavy participation from HVAC manufacturers and their trade associations. The American Society of Heating, Refrigerating, and Air Conditioning Engineers built its entire thermal comfort framework around compressor-driven systems. Desiccant-assisted cooling received no residential performance pathway, no compliance credit, no mention in the calculations that determine whether a home meets energy code. Open the International Residential Code today and you will find detailed specifications for every type of mechanical cooling equipment. You will find nothing about desiccant pre-treatment of ventilation air for homes. This was not an oversight. ASHRAE technical committees that write these standards draw membership overwhelmingly from HVAC equipment manufacturers. The people who write the rules are the people who sell the machines. When desiccant cooling was proposed for residential pathways, the response was always the same: insufficient domestic performance data. Meanwhile, 3 decades of European documentation sat in published journals that anyone on those committees could have read. The Building Officials Association has opposed amendments recognizing passive and desiccant cooling alternatives in state codes, citing inspection complexity and liability. The real arithmetic is simpler. Every desiccant system installed is a compressor that never gets sold, a refrigerant charge that never gets refilled, a service call that never gets billed. A $130 billion industry cannot afford a $10 bag of salt doing half the work. Your HVAC contractor is not hiding this from you on purpose. He was never taught it. His licensing exam never mentioned it. His supplier does not stock it. The knowledge was removed from the training pipeline so cleanly that the absence itself became invisible. Contractors cannot recommend what their education never covered. Inspectors cannot approve what their codes never included. The result is a country full of air conditioners working twice as hard as they need to because no one in the residential supply chain knows there is another way. Now, if you do not own land, if you are not off-grid, if you are sitting in a suburban house or an apartment right now, stay with me, because what comes next works in any home, costs under $300, and requires 0 permits in most jurisdictions. This part was built specifically for you. Here's the number I promised you at the beginning. In a humid climate, your air conditioner spends between 40 and 60% of its total energy consumption on moisture removal alone. not on cooling, on wringing water out of the air. The National Renewable Energy Laboratory confirmed that desiccant pre-treatment of incoming air reduces cooling energy demand by 40 to 80% because the compressor no longer has to chill the coil below the dew point just to condense water. It can run a warmer coil focused entirely on lowering temperature. That single shift transforms the effective efficiency of any air conditioning system. Your 3,000-watt compressor starts performing like it gained a free upgrade, not because the machine changed, because the air reaching it changed. That is the principle. Now here is how you use it. The entry-level approach costs about $10. Go to any hardware store and buy a 40-pound bag of calcium chloride in the de-icing aisle. This is the same active ingredient inside DampRid products, but at a fraction of the price per pound. Calcium chloride is a powerful desiccant that absorbs moisture from the air on contact. Place 1 to 2 pounds of dry crystals in a shallow plastic container with ventilation holes in the lid. Set the container near your return air vent in the room where your thermostat lives. As air circulates past the crystals, they pull moisture out before it enters the duct system. Replace the crystals when they dissolve into liquid. In a humid climate that happens every 3 to 5 days. Be honest about scale. A single tub of crystals will not dehumidify an entire house. It will noticeably reduce humidity in the room where it sits, and that room is where your thermostat reads the air. When the thermostat senses drier air, it registers comfort at a slightly higher temperature. Your compressor cycles less, your bill drops. This is not a gimmick. This is the same physics that saves that Georgia greenhouse owner $40,000 a year. You are applying it at a smaller scale with a smaller investment. For the full system upgrade, the next step costs between $200 and $300. Install a standalone whole house dehumidifier on your return duct. Units from April Air, Santa Fe, and similar manufacturers are designed to handle the latent load independently. They strip moisture from the air before it reaches the evaporator coil. Your air conditioner then handles only sensible cooling. The two machines together, each doing one job, outperform one machine doing both jobs poorly. This is exactly how commercial desiccant systems work. You are simply building the residential version that the industry never offered you. 3 critical safety notes. Calcium chloride is exothermic, meaning the crystals release heat as they absorb water. Keep them in a ventilated container away from sealed spaces. The dissolved brine is corrosive to metal, so never place open crystals inside ductwork or directly against HVAC components. And always set your container on a tray to catch liquid, because when the crystals saturate, they turn into a puddle of salt water that will damage flooring. The materials list is short. One 40-pound bag of calcium chloride ice melt at roughly $10. 2 or 3 shallow plastic containers with ventilation holes at about $5 total. 1 digital hygrometer to measure your results at about $12. Total cost under $30 to start. You will see a measurable humidity drop in the first 24 hours. For the viewer who wants the complete system, a standalone dehumidifier on the return duct plus calcium chloride supplementation in high humidity rooms creates a layered approach that mirrors what industrial buildings have used for decades. Your air conditioner becomes a sensible cooling machine only. Your energy bill drops. Your compressor lasts longer because it runs fewer hours under less strain. And the salt that makes it all work costs less than a fast food meal. The cooling industry built a $130 billion business on the assumption that one machine should do everything. That assumption was never about physics. It was about profit margin. The physics says separate the jobs. Remove the water first. Cool the air second. Your grandfather would have understood this instinctively. The only reason you did not is because the people who trained your contractor made sure he never learned it either.